Hello. Welcome to Principal AI's AI System Design series. We make system design videos to help you learn basics to more complex designs in a structured way. If you like our videos, please subscribe, like, and leave a comment. In today's video, we are going to introduce you to a very simple concept called vector databases. You do not need any prior knowledge to understand this concept. Before we ask what vector databases are, it is helpful to understand another concept in generative AI. It is called R.A.G. R.A.G stands for Retrieve Augment and Generate. As you know, large language models are used to generate text based on a prompt. The input is a prompt and output is text. The models are trained on billions of inputs that are collected from all sort of sources through a complex and expensive process. For example, the model might be trained on financial information of many companies over the years. It can also answer the questions you might ask it specifically, such as, can you summarize to me three major highlights from the Q1 reports of Meta in years 2024? If the model was trained on this data, it will be able to answer it. However, what happens if you want the model to find three highlights from an investor report that is for your organization and is confidential? In that case, the model is not trained on it. So what you do is you provide the document to the LLM as part of prompt. Given this text of our investor report, please summarize three major highlights for me. In this case, we manually retrieve the document, provide it to LLM, and LLM generates an output. The LLM uses its own training to understand the provided document. This is called augmentation. The final step is generation. So this is what R.A.G stands for. Retrieve your private data. Augment the knowledge in the data with the knowledge of the model. Generate new output. In more complex scenarios, you might want to ask the LLM questions that are about massive datasets in your organization. For example, if you are a law firm, you might want to ask you LLM, given the following facts of the case, find me all the case laws that might be relevant. Also, given the history of all the partners at our law firm, suggest to me the best possible partner to handle this case. Here, the LLM might be able to use its own knowledge of case law to give an answer, but to answer the second part of the question, it needs to know all the partners at the law firm and their history. The LLM would need to know all their cases, results, and ability to argue, etc. This data is far too large and is unstructured. Also, LLMs have limited context window, which means their input is limited to few thousands or million tokens. So you can't just give it entire data, but you have to extract the most relevant data from your total data and give it to the model. This is precisely the problem that vector databases solve. If you store all the data of your law firm into a vector database, it is much easier to query the relevant data from that dataset and then transform it into a prompt that large language models can understand. Vector databases solve the problem of efficiently storing, searching, and analyzing high-dimensional vector data. This type of data is often generated by machine learning models and represents complex objects like images, text, audio, and even user behavior. Traditional databases struggle with this kind of data because they are designed for structured data in tables and rows. Vector databases excel in handling unstructured data such as emails, web pages, PDF reports, blobs of text, images, etc. Vector databases allow us to improve the accuracy of our AI system by providing better facts to the model. It also allows us to provide more recent data to the model as part of the prompt, and this improves the relevancy of the model output. Additionally, this allows us to keep our private data private and never allow training the model on that data, and yet use that data for specific queries related to that very data. Another often overlooked advantage is the explainability of the result. Large language models often do not tell us which training data they used specifically to produce their output. But with vector databases, they can tell us which documents were used to make the inferencing. This helps us fine-tune our systems better. Let us look at an example. If ask our AI system to extract three highlights from all the major public companies' quarterly reports for the current quarter. This data is recent and hence not part of LLM's training data. The first step here is to load as many quarterly reports we can into the vector database. The database is responsible for transforming the reports into a format called vectors. The next step is querying this data in the context of the prompt you want to provide to the LLM. This is the step where vector database performs a search and returns a result in the form of vectors. Note that LLMs do not understand vectors, so the vectors need to be converted into text that the LLM can understand. This is where prompt engineering comes into play. The results of the vector database will be transformed into a prompt that the LLM can understand and will be provided as a giant text. What you really need to understand is that the LLM is your chef who is preparing the dish called output. R.A.G. is the sous chef who goes to the pantry of vector database, fetches all the relevant ingredients, and gives it to the chef. For the right output, you need a good, well stocked pantry, a good, smart sous chef, and a chef. We will soon publish a video about RAG systems soon. To get notified, please subscribe to the channel right away. Hopefully, we have explained the idea of vector database to you well enough that we can actually go into the details soon.